Hello everyone. My name is Prince Kumar Singh. Right now I'm in my third year. Today I will be presenting my uh, one of the project that I had made. It's KNN from scratch, where I had yeah, it's kind of simple, like where I had used Euclidean to calculate the distance between points. So let's just jump back to the code. So yeah, first we'll be importing the libraries and. Afterward, yeah, in KNN, it's very important to normalize the data uh, because of multiple reasons. Uh, what are the reasons? Systematic, uh, costly. Why? Why? Mm, Why? Uh, Pros and cons to data standardization, normalizing of standardization, and why? Let me- Because can is a certain distance between two points. And distance is sensitive from magnitude. Basically, Euclidean is sensitive to magnitude. Euclidean distance is sensitive to magnitude, and feature with high magnitude will weight more than okay. Yeah, so because here we are using Euclidean distance to Euclidean to calculate the distance, and Euclidean is uh, Euclidean while we are calculating distance with Euclidean, it's kind of uh, magnitude sensitive. Okay, so if it will be giving more weightage to the features with high magnitude uh, compared to the features with low magnitude. That's why here we will be normalizing it. So for that, I had used Z-Discourse to normalize the data. And here we had fit transform and fit transform. And this is our main class where we had first fit the data. If we see the original KNN, so there we will be storing the data. Like it's kind of different if you see compared to the on this linear regression and logistic regression. In fact, we used to do pre-processing, but here fit is used to store the data. But originally, if we see in sklearn we like the fit is used to store the data in tree structure format, though here we had simply stored the data, and afterward we had a method called Euclidean distance where we will be calculating the distance, and afterwards we had a method called predict where we'll be predicting the basically here all the processing here we will doing all the calculations. So first, yeah, we had defined, we had an prediction array, and afterward, we will be calculating distance. Yep, and storing into the distances like this. We will be storing our distance in this variable, and afterward, with k index we will be in this k index we will be storing our values till k, like it depends on the user, like which like like how many neighbors he wants uh, while calculating while calculating while calculating or while predicting, okay, the data. And this k index will do what? It's okay. So basically, it will store till k neighbors, till k shortest neighbors. And in k label, we will be doing what? Yeah, so basically in K labels have dot y trade index. So basically here, mm, yeah, basically here we will be storing the values of those values, which is our K index. And afterward, we have two variables. One is value and values, and the second one is count. In values, we will be storing the values of has unique values, like which is in the array. Basically in this mm, okay. And okay, so it will here will be storing our unique values, and the count will be that unique values. Like let's suppose we have 0 and 1. So here we have 0 and 1, and count it's like the number total count of that values. Like if in K label, let's suppose if I have uh, zero or like 5 times 0 and 1 time 1. So like here we in values I will be getting 0 1, and here I will be getting 5 comma 1 array. Okay, in an array, and in the prediction what we'll be doing, we will be appending the values, like the max values. Like what's the argmax? So basically it will return it will return the index. Okay, it will return the index of the highest counted values. Like here we, let's suppose what we had taken the example, we like 5 zeros. So we have 5 zeros. Okay, so it will return the index. It's gonna be 0. Okay, and in values it will return the prediction value 0, which is again 0. In prediction, it will return that same thing in array format. And then afterward, this is the data we had generated using ChatGPT. And afterward, yeah, this is this all this process and that simple thing, and let's just see if it's working or not. So for that, we had initialized the data, and trained it, and then predicted the values. And afterward, yeah, we used classification report to check how much accuracy we are getting. Like with so there's like in that using KNN. So it's kind of pretty high. It's 97%. So yeah, that's it. It's very easy. And yeah, because it's a simple one. Even the hard one is easy, but okay, that's it. That's it.